Hello everyone, welcome back to our channel. In today's video, I'm going to explain the solution for a common asked questions in the top 10 software houses. It is known because it includes binary search approach in different ways. And it is also a second version for a previous exercise that I already solved in that channel. That being said, let's start with the exercise. Before we start, if you didn't have a look at the previous video, finding an element in a sorted collection, I really recommend you to take a look because this video is a second version for that exercise. So in this exercise, we are going to try to find an element in a rotated sorted collection. So we have an additional layer of complexity, which is the rotation of the collection. So where to start and how to find a solution? As usual, the first step consists of understanding the problem. So we should try to elicit the requirement as much as we can. And as usual, one of the tips is asking, for example, let's take the collection A equal to 5, 6, 7, 1, 2, and 3. And we need to find the target value 1. So where is it? Where is the value 1 here in that collection? We can see that the value 1 is present at the fourth position, or the index number 3. That's true. But automatically we can think of a negative test case. So for instance, let's try to find in that same collection the target value 8. We can see that in that collection we don't have the value number 8. So what should be returned here? So here it is a dialogue between you and the interviewer. So you can ask him what you need to return in case the value is not found. Sometimes they will let you decide the best solution for you. In that case, you can propose two approaches. Even you return the -1, so let's say a negative number, or you can throw an exception stating that the value was not found. That being said, after having understood the example, as usual, a good practice is to rephrase the question and the problem. It is a good way because you will be able to be sure that you are on the same line with the interviewer. After having rephrased the question, let's start with the implementation. So after having understood the question, rephrased the problem, we need to think about the solution, the implementation. So a good way to start is to take a look back at our examples. We can see in our previous examples that we had a collection A equal to 5, 6, 7, 1, 2, 3, and we need to find the target value 1, and we found that the expected output would be the index number 3 because the element is at the position 4. But how did we find the solution? We can obviously think about a standard and a brute force approach, which consists of iterating over each cell and every time checking if the value corresponds to the target value. If it is the case, returning the index, otherwise returning the -1, which corresponds to not found index. But we can automatically see that it is not the best implementation because if we have a collection of millions of elements, we can see that we will have to iterate over millions of elements just to find this target value. However, we have some hints in our problem here. We know that this collection is sorted. So as usual, try to find some hints in the problem, in the question, and also try to use your algorithmic skills. So we know that this collection is sorted. And we know when we have a sorted collection, we can apply a binary search approach. Yeah, it's true. But how can we apply it here? So we know that this collection is sorted but rotated. So we have two problems here. The first problem is a rotation of the collection, and the second one is finding an element in a sorted collection. So how should we proceed here? We need first to find this pivot, this rotation index in our collection. After having found this rotation point, we can automatically apply the standard implementation on a sorted collection. So our problem is back to a small problem, which is finding this pivot in our sorted collection. Let's try to find the correct implementation for that type of question. How can we find this pivot? As usual, there is no magic. We have to come back to our example. So let's take a look at our example. We can see that we have the value 5, 6, 7, 1, 2, and 3. We can see that from 5 to 7, all the values are still in a sorting order until the value 7 is reached. And we can see automatically that the next value is smaller than 7. So we can see that starting position 2, all the next elements are smaller than the value. So we can automatically see that the rotation happened at position 2 and the pivot is at position 2. But what's the correct implementation to find this pivot? The obvious implementation is a brute force approach, which consists of iterating over each element, and as soon as the next element is smaller than the current element, we consider that we reached this pivot. However, it is obviously not optimized. We are not leveraging all the parameters in that problem. If we look at our collection, we can see that from value 5 to value 7, all the values are ordered. So we can see that we have pieces. We have 2 pieces in our collection. So why iterating over each cell? Instead of doing like that, we can apply a binary search approach. We can take the middle element in the beginning, and we can start comparing this middle element to the next value. If this value is smaller than the next value, we did not reach yet the pivot, so we have to continue our binary search to the left and to the right. In that way, we found our pivot with a logarithmic complexity. So let's try to implement it now. I will be writing the code in C++. So let's start. So I will be having 2 functions here. The first one is going to be called find pivot, that takes in parameters the values and return a size t, so an unsigned integer, which will correspond to the index of this pivot. And I will be having another one called find pivot rec, which will be serving the recursion approach. So let's start with it. So we have size underscore t find pivot. It takes as an argument the vector of int. It will be called values, and we will be calling as an only statement find pivot rec. We give it the values, the start index, and the end index. The start index will be 0, and the end index will be values.size minus 1. So let's now try to implement the recursion function. We will call it, as we said, find pivot rec. The return value will be of type size t. It takes 3 parameters this time. It will take the vector of int, so array, the size t start, and the size t end. So how to implement it? So as usual, when we try to implement a recursion function, we should think about the base case and the recursion case. So the base cases are if the end is lower than the start, so we already did all the iteration, let's say, we have to return -1 because we did not find any value, so any pivot here. If end is equal to start, so we are searching in a collection of size 1, so in that case we found this pivot, so return start. I think that those are the 2 base cases for now. So let's try now to find the middle element. So let's first compute the middle index. So we have size t mid equal to start plus end divided by 2. We are going to compare first to verify that mid is lower than the end, just to be sure that we are not out of bounds. So we compare if mid is lower than end, and now we can compare the mid with the next value. So if array of mid is greater than array of mid plus 1, so in that case we reached our pivot, so we can obviously return the mid, so return mid. Otherwise, we did not reach this pivot yet, so we have to check this pivot, so this mid element with the one before. So first we have to check that mid is greater than start, just also not to be out of bound. So we check if mid is greater than start and array of mid is lower than array of mid minus 1. So we also reached our pivot, but this time the pivot is at the position mid minus 1. So we return mid minus 1 here. Otherwise, we did not reach the pivot yet. So in that case, we have to apply this function in one of the two sides. So on the left or on the right. So to know if we have to apply it on the left or on the right, we can compare the start value with the mid value. So if array of start is greater or equal to array of mid, we know that the pivot will be on the left. So we have to call return find pivot rec. We pass the array as usual, the start, and the mid minus 1. Otherwise, we know that the pivot is on the right, and we have to call return find pivot rec. We pass the array, the mid plus 1, and as the last index. So I think that's the implementation for now to find the pivot. To be sure that it works correctly, let's try to apply our example. So we have a equal to 5, 6, 7, 1, 2, and 3, and we need to find this pivot. So we will be calling first find pivot, passing a, the first index, so start will be 0, the end will be 5. Find pivot rec will be called first with those parameters. We are going to check the base case in the beginning. So is 5 lower than 0? No. We are going to skip the first if statement. The second base case will also be skipped because 5 is not equal to 0. After that, we are going to compute the mid index. So we are going to have 0 plus 5 divided by 2. So we are going to have mid index equal to 2. We are going to pass into the next if statement. Is 2 lower than 5? Yes. Is array of 2 greater than array of mid plus 1? So is 7 greater than 1? Yes. So we are going to return the mid index, which corresponds to 2. And in that case, and in that way, we found our pivot index. So it seems to work correctly. In your interview, it is recommended to take another example also just to be sure that it works. Another type of example, another type, for instance, where there is no pivot, just to know that it works correctly, and it will return you, in that case, for instance, the last index, because there is no pivot, or at least the minus 1, sorry. So now, how should we proceed? We found the pivot index, so we now have two sorted collection, and we need to find that target value. So obviously we will need that pivot, and depending on that pivot, we are going to check, should we search into the left side or into the right side? So should we search for that target value in the left side of this pivot or on the right side of this pivot? So let's try to implement it together. So we have this function which will be called find, and it will take as the first parameter and only parameter the array. It will return the size t, so an unsigned integer, which will correspond to the index where we found this target value. So the first statement will be find pivot. So we are going to call the function that we implemented previously. So we will have a size t pivot equal to find pivot. We will pass array. Yeah. After that, we are going to check if we found this pivot index. So if we didn't find this pivot, so if pivot is equal to minus 1, so it means that this collection is not rotated. We can obviously search in all the collection for that target value. And as I mentioned previously, we are going to apply a binary search here. But I'm not going to implement the binary search function. If you want to look and understand how it works, there is another video in that channel where I implemented how to find a value in a sorted collection using the binary search approach. So I will assume that I have this function, binary search, that takes 3 parameters, the array, the start, and the end, and also the target. So it takes 4 parameters instead of 3. So we are going to check first. Is pivot equal to minus 1? Yeah. So we are going to search into the whole array. So return binary search. We pass the array 0 minus n minus 1, which will correspond to the array.size minus 1, and the target value. That's for the first case, so if the collection is not rotated. Now, if we found this pivot, we need to know where should we search, on the left or on the side. Before searching and taking that case into consideration, we can compare, obviously, if the position of this pivot corresponds to the target value. So we do if array of pivot equal to target, we return the pivot. Otherwise, we need to decide now where to search, on the left or on the right. An easy way would be to compare the first element of the array with the target. So if array of 0 is lower or equal to the target, it means that the value is on the left side, so we can compare and search on the left side of the collection. So return binary search, we pass the array, the start index will be 0, the end index will be pivot minus 1, and we have this target value that is going to be searched. Otherwise, we have to search on the right side, so return binary search, array pivot plus 1, array.size minus 1, so n minus 1, and target. That being said, if we take back our example, so the a equal to 5, 6, 7, 1, 2, 3, the pivot index, so the first statement that will try to find this pivot will call find pivot. It will pass array 0 and the n minus 1, so 5. The pivot that will be returned would be 2. We are going to compare is the 2 equal to minus 1, so it is not the case, so we have a pivot here. We are going to first test if the array of 2 is equal to 1. So since 7 is not equal to 1, so we are going to return to continue, to skip that if statement. After that, we are going to compare array of 0. So it was 5. Is 5 lower than the target? So is 5 lower than 1? No, it's not the case. So we are going to skip also that statement, and we are going to apply our binary search on the right side of this collection. So return binary search array pivot plus 1, so 3, 5, and the target would be 1. With that final statement, we can say that our solution is ready, and we were able to implement and to leverage the binary search approach for that question. Finally, I hope that the solution was clear for you, and as usual, don't hesitate to add your comments and your own implementations, and please don't forget to like and subscribe for future videos.